Hello, fellow lecturers and friends. Today we are going to present to you our second intro to engineering and design project about the rescue delivery system. Our group member F consists of Aryoga, Irsyad, Shan, Hugo, Annamaria, Zieldan, and Mario. So, in this project, we are required to create a glider that can fly with 14 grams of loads for 8 meters. And we are required to carry payload of 2 chalks, about 14 grams, and the glide distance of the target is 8 meters from a table of 75 centimeters high. There are one material that is not allowed to use in this project, which is styrofoam, and there are possible alternate materials that we are possible to try, which is balsa wood, 3D printed PLA, carbon fiber rod, paper, can, Lego for the launcher, PVC board for the launcher. At last, for our group, we used balsa wood and paper for the glider, and also we use carbon fiber rod for the tail boom, and for the launcher we use balsa wood with some aluminum foil to reduce friction.
I will be explaining the DRO for the glider and the launcher. For the glider, under the geometry category, we have two demands. The demands is that the wingspan of our glider will be between 200 and 600 millimeters, and the overall vehicle length needs to fit the 2000 millimeter diameter landing area. We also have three wishes. We wish that we have a high aspect ratio wing for efficiency. We also wish that the total weight of the payload with the glider is under 100 grams, and we want a landing skid to cushion the landing. Under the material category, we are not allowed to use styrofoam, that is a demand. And our wish is that we use a high strength to weight ratio material like balsa wood. Under the performance category, there are three demands. One is we need to carry 14 kilograms of payload, which is 2 pieces of chalk. We need a minimum glide ratio of 1 to 11, and it needs to have good structural integrity. We also have one wish, which is for the glider to be able to maintain a straight glide path. For the cost, we're aiming to shed out 500,000 rupiah to create 5 prototypes and 3 launchers. For the manufacture time, we wish that the manufacture time takes less than 2 days. And for the safety, we wish for there to not be any sharp edges, and there's demand for the payload to stay intact. Now the DRO for the launcher. Under the geometry category, the length needs to be under 500 millimeters, which is demand. Another demand is the rubber band. We need to use less than 6 rubber bands, or 6. And the launcher needs to have a track to guide the launch direction of the glider. And we wish that the launch angle be adjustable. For the material, it is demanded that we only use rubber band powered propulsion. And under the performance category, we wish for the glider to be able to propel glider to speed. We wish for the launcher to be able to propel the glider to speed.
Hello, my name is Zieldan Maditya, NIM 169211305. So this is the design alternative for the glider. So there's a total of 6 designs that we use, but in the end we actually used the 5th one because of a couple of reasons. Well, I'm gonna show it to you after this, but there is a total of 1, 2, 3, 4, 5, and 6. So this is the features of the design. We have 1, 2, 3, 4, 5, and 6 features that we need to calculate to actually use in the end. So the features of design table suggest that we use design 4 and 5, but we ultimately chose to go with an alternative design of design 5 because the tail plane is located above the fin to maximize the glide potential. So from all of this design, the total score, the highest score of the design is in the fourth and the fifth, but we use the fifth one. Thank you and goodbye.
Now, I'm gonna talk about our launcher. This is the 6 alternative designs that we came up with. And on the next slide, there is features of design of each launcher alternative. As you can see on the table, launcher 1, 2, and 5 are the only one that match our DRO, whereas design 3 does not have any track to guide the launcher's direction. Design 4 need too much rubber band to be only rubber band powered launcher, and design 6 may need more than 6 rubber bands. Therefore, we decided to build our first launcher prototype following design 2. But since it breaks down way too often, we decided to make a new one similar with design 1.
Next, you're going to discuss the detailed design of the glider. Our glider has a wingspan of 58 centimeters and a length of 37 centimeters. Our glider features a T-tail empennage design, and on the tip of each wings, we have fitted a set of winglets. Our glider also has adjustable elevator, rudder, and aileron trim tabs, which can be used to counteract any instability. Our glider is mostly made out of balsa wood, which is bound together using CA glue. For strength and rigidity, we are using carbon fiber rod for the tail boom. For any surfaces that might contact the ground, we are protecting them using EVA foam or bicycle inner tubes. The bicycle inner tube is used on the skid pads, and for additional friction, we have added the double-sided sticky tapes. And for the wings and tail, we are covering the balsa structure with covering tissue for aerodynamics and lightweight. And finally, for the control surfaces, we are using foil tapes.
This is the detailed design of the launcher. It has track to guide launch direction. It has length of 500 mm. It uses 6 rubber bands. The rubber band is tied to the front of the launcher. The launch angle of the launcher can be adjusted. The launcher fulfilled our DRO. This is the picture of our launcher from different perspectives.
Okay, so I'll be talking about our group's reflection on this second PEDE project. Firstly, it's about the testing day. The test results conducted by Aryoga, Shan, and Zieldan. During the testing day, the glider landed 3 times in the target, which the distance from the launching table to the target is about 8 meters, and the glide ratio is 1:11. Nextly, we'll be moving on to the skills that we learned or enhanced in the second PEDE project. Firstly, we learned more how to cooperate, how to teamwork with each other, how to help each other, and so on and so forth. And second, we learned how to measure precisely, about precise measurement. And third, we learned that we need to test multiple prototypes in order to find the best one out of them all, and also to improve. And to improve, we also learned that we should brainstorm. And then next, finally, is about the improvements. In relation to this reflection, the improvements are that we provided proper launch elevations for the launcher, and besides that, we reduced the weight of the glider by using composite materials. And I guess that's it for the reflection part. Thank you.